Okay, awesome, guys. And you did mention that you can see my screen, so it means we are good to go. So let's start and have a look at the problem which was sent by one of yourselves. In fact, this is not an arithmetic sequence, it is a quadratic one. Let's quickly fix that. Okay, so let's have a look at what is happening. So the problem, let's take it to the next page and have a read of what is happening. So what we need to note here is that what we are working with is a quadratic pattern. So the statement reads, the sequence of the first differences of a quadratic pattern is given by that. Okay. And then we are told that we have T99. If T99 of this quadratic pattern is given by that, then we should calculate the term T98. So let's think of what is happening here. And one thing you should note is that we are working with a quadratic pattern. And what we are told is that what we are given is not the quadratic pattern, but the first difference of the quadratic pattern. So we have the first difference. And what is this first difference? This first difference is 1, 3, 5, and so on. So just to make sure that you guys understand what this first difference means is what we had here, we had T1, and then we had T2, and we had T3, and we had T4, and so on. And how the second or the sequence which we have comes about, it comes about as a result of these differences here. So when we take these differences, what we end up having is the sequence that we have here, which is that we'll have a term which is 1, and then 3, and then 5, and so on. Okay? Then if you think of what is happening here, we'll eventually reach term 88, sorry, term 98, and term 99. And the difference of these terms will be something that we have somewhere there. Okay? We'll have the value to be something. But do you see that if we can get the value that sits here, then what we can get is what is T89? Because, sorry, what is T98? We can easily find that if we can find what is the value that sits there. And let's call that X. So we'll call the value that sits there, the difference between these ones, X. So if you do T99 minus T98, we know that that should give us X. And guess what? What we are looking for is T98. So this means you can transpose this one to the side and this one to the side, such that your T98 becomes your T99 minus X. That is what should happen. Okay. And if you look carefully, all what we need now is to figure out what is this X, because T99 we are given. T99 is simply 9,632, and this is given. So all what we need is X in order for us to determine what is T98. So now let's think about this carefully when we look at this sequence of the first difference. So when you look at the sequence of the first difference, guys, how I want us to think of it is that this term here will be term 1, this will be term 2, this will be term 3, and so on. So if you think about it carefully, the term that we will be having here at x, which is the difference between term 99 and 98, what term is that going to be if we are trying to make a new sequence? What term will that be, guys? What term is it going to be? So look at what happens. So that becomes that becomes that becomes that. So what term is this going to be on our sequence, which we are going to form using this first difference? It is going to be term 98. Okay. So now all what this means is we just need to go and look for term 98, because this first difference here, we know it is an arithmetic sequence. So that first difference there is an arithmetic sequence. Let's go and work it out. So that is very important. The first difference of a quadratic sequence is an arithmetic sequence. So that difference will be arithmetic. Why is it an arithmetic sequence? It is because the difference that follows the second difference will be constant. So we have 1, 3, 5, and so on. So let's find the common difference here. The common difference will be 2. 5 minus 3 will be 2. So this means our D is 2 and our A is 1. That is what we have found. Our D is 2, our A is 1. And guess what? We can now find our Tn for the arithmetic sequence, which is A plus n minus 1 times D. The value of A we do have, so we'll have our Tn equals the value of A is 1 plus n minus 1 times the value of D, which is 2. So if you look at what happens, you'll have 2n minus 2 plus 1. So our Tn will simply be 2n minus 1. And this, remember, guys, this Tn here is for the first difference. So we can find the difference, the first difference at term 98. Because once we know that, we know what the x is. So we know that T98 is x, of which all what we need to do, wherever we see n, we put 98 minus 1. So what is the answer, guys? 2 times 98 minus 1. What do we get as T98? Can you please repeat? T98, I'll put in prime for the first difference. What do we get?
195, sir.
195. So for the first difference, we are just going to put primes. And we know that this will be x. So it means now we are in a position to go and find the actual T98. Okay, so let's go ahead now. If you observe carefully, T98 is the same as T99 minus x, or T98 prime, which is just the difference there, which is just minus that x, which is the same as 9,632 minus 195. So what do we guys get is T98. What is the answer? So the dash there at the top says that it is the T98 of the first difference, not what we are looking for. What do we get as the answer, guys? What is T98?
9,437.
So 9,437. Done with that. Let's have a look at the next question, which is 2.2.2. So it reads, if it is further given that the third term of the quadratic pattern is 32, so let's make a note of that. So T3 is 32, Okay. Then they say determine the general term Tn of this quadratic sequence. Okay. So what we now have is actually three terms. Think about it. What we have is T3, which is 32. We also have T99, which is 3,000. Sorry, it is 9,000. 9,632. And we also have T98, which is the same as 9,437. So now in this question, what they are asking us to do is to figure out what is Tn. And we know for a quadratic sequence, Tn is given by an squared plus bn plus c. So in other words, we need to go and figure out what is the value of a, what is the value of b, and what is the value of c. So let's go to the next page with all of this and go and figure that out. Let's just move this away. Okay, let me paste this here. So all what we need to do, guys, we just need to remember our formulas. So the value of a, if you remember, how you get a is we use the second difference. That is how we get the value of a. So we know that the formula that we use whenever we are looking for a is that 2a equals the second difference. So let's see what this means. In our problem, if you remember, we were given the first difference. And that first difference was 1, 3, and 5, I think. Let me confirm. Yep. So it means when we take the difference here and we get 2 and we get 2, what we then get here is what is called the second difference. So this means that 2a, 2 times a will be equal to 2. But remember, we are looking for a because it is one of the things that we don't know. So we must divide by 2 and divide by 2. So therefore, the value of a is 1. Okay, that is what we have found. Now we need to figure out what is the value of b. What is the value of b? And if you remember, whenever we are looking for the value of b, guys, again, we use a formula. Which formula do we use? Whenever we're looking for the value of b, we use the formula T2 minus T1 equals 3a plus b. Okay, now we need to figure out what is T2 minus T1. T2 minus T1 becomes the first term on the first difference. So if you observe carefully, do you see that the term that sits here, which is this one is simply given by T2 minus T1. So T2 minus T1 is simply 1. Okay. So this means I'm going to go here and equate this to 1. And guess what? The a we already have as 1. So I'm going to have 3 times 1 plus b equals 1. So we are going to transpose the 3 so that we end up getting a value of b, which will be 1 minus 3, which will be minus 2. Do you guys understand?
Yeah, we understand, sir.
Okay.
Yeah.
Awesome. Yes.
Are you making an example or are you answering the question?
I'm actually answering the question.
Oh, okay.
Do you have any confusion anywhere?
No, sir, it's fine.
Okay. So we found the value of B. Now what we need to find is the value of C. But for C, if you remember, you guys were taught that you can use, for C, what you should note, maybe what you are not taught, you can use any term to find C. We can use any term. And guess what? We are given term 3. So the other terms are very big. We don't want to use them. So remember that we are given term number 3, which is 32. And we know that Tn is always the same as an squared plus bn plus c. So what I'm going to substitute is everything that I know. So Tn, I know it's 32. The a we found is 1, guys. The n is 3 all squared. The b we found is minus 2 just above. So the b there we just found is minus 2, and the a, where's our a? Our a we just found as 1. Okay, so minus 2 times n, which is 3, then plus the c, which is what I don't know, and that is what I'm looking for. So I end up having 32 equals 9 minus 6 plus c, and this ends up becoming 32 equals 9 minus 6, that is 3 plus c. And guess what? We can transpose the 3 to the other side, such that the value of c becomes 32 minus 3. And what is 32 minus 3?
29.
We get 29. And guess what? We can now smile, guys, because we have all the values which we need for us to give them the final answer. Because they were asking us to determine, look carefully, Tn. So we now know A, B, and C. So our Tn will now be equal to, for A, it is 1, so it will be 1n squared. For B, it is minus 2, so it will be minus 2n. Then for C, it is 29. So I can remove the 1 there. That, guys, becomes our answer. So I want us to check if this answer is indeed true. But this here is our answer. So how are we going to check this? We are going to check using one of the terms that we are given. So let's use term 99, because term 99 was given. So we want to check if our formula works. So I need you guys to go and substitute wherever you see n, put 99, then go to your calculator and let's see if we will get the answer which we were given there. 99 plus 29. So let's punch this on our calculators and see what we get. Anyone?
9,632, sir.
632. So let's see. Okay, so when we test the formula we found, we get 9,632. So because we were given when we were starting T99, let's see what it was. It was 9,632. So this means what we found is correct, isn't it, guys? It means our formula actually works. Yep, it does work. Do you guys understand? Give me a thumbs up if you do. And please ask a question if you don't. Very important that you are able to make sense of all the steps which we took here. Okay. So that brings us, guys, to the end of answering this question, which was shared by one of your classmates. So this is the question, and we have done all the work to get to the final answer. So if there's no question, then we can pause here for today, and I'll be on the look for any homework help questions which you guys send. Any question before we leave? Okay, no question, guys. Cheers and take care. I hope you learned a lot in this session. Bye-bye.